All right, so now we move on to lesson 6 of relations and functions, and it's dealing with parallel and perpendicular lines. Now, the nice thing is up until this point, we've dealt with slope formula, we've dealt with slope-intercept form. We have all the tools we need. Now it's just figuring out what does it mean to have parallel lines, what does it mean to have perpendicular lines, and what does that mean about their slopes. So starting off with our investigation here, for each of the points below, we're going to plot the points and connect them with a line segment, state the slope of each line segment, and then finally write down any observations between the line segments we find. So what we're going to do is we're going to start off with number 1 with A, B, C, and D. If I plot A, B, C, and D, well, first of all, I need to label my X and my Y axis. I then go to the points, and I'm going to do A and B in blue. So if I do A and B in blue, well, I go to -4 and -1, which puts me in a point here. And then I have -1 and +5, which puts me here. And therefore, what I'm going to do is I'm going to draw a connecting line between those points, and I'm going to label this as A, this as B. Okay, now I'm going to go on to C and D, which I will also do in blue here. So C and D start at point C, which is 1 and 1, and then we go to 5 on the positive axis or positive x-axis and down to -1, meaning here is our line segment here. And it connects those 2 points there. And maybe I'll just redraw that just to make sure I go over that a little more accurately. Perfect. Now I'm going to label these. I have C and D. Okay, what do I notice about these lines? Well, first of all, let's calculate the slopes for these. From A up until B, how many did I have to go up? How many did I have to go over by? Well, it looks like I have to go up by 1, 2, 3, 4, 5, 6, and I have to go over by 3 units. We know if it's left to right increasing that the slope is going to be a positive value, and more specifically, my slope is equal to rise over the run, which is equal to 2. So I'm going to write this down off to the side that we have a slope value of m is equal to 6/3, which is equal to +2. Now I'm going to do the same thing with C to D. But C to D, I realize it's slightly different. I have to go down between them and right by a certain amount of units. I go down -2 and then over by 1, 2, 3, 4 units. And so with this slope, I have an m value equal to the change in y, which is -2, over the change in x, which reduces down to -1/2. So off to the side now, I'm going to go, our m value is equal to -1/2. Now, what do I notice? When I compare these two slopes here, I see that one is a positive and one's a negative, but I also see that they're the reciprocals of each other, 2 and 1/2, positive and negative. So we see that it is the negative reciprocal, and we would describe these lines, B and A and C and D, as perpendicular. They form this 90-degree angle between the 2 line segments. They form this almost T-shape or a 90-degree angle in their line segments. Now, if I go down below here, E, we're going to do E in terms of a red graph, or E and F and G and H in terms of a red graph. So I'm going to go to -6, which puts me here on the X, and then down to -2. Here is my first point here, which I will call point E. And then I'm going to go to point F, which is -3 and +3, which will put me right here. Now, I'm going to label that as F, and then I'm going to do a connecting line segment between those points there. Not the most accurate of lines, but that is the line segment there. Okay, now we're going to plot G and H. G starts at 2 and 0, which is here. And then it goes to H, which is at 5. So 1, 2, 3, 4, 5, and up 5 units, which puts us here. So I'm going to label that as H, and then finally I'm going to connect these 2 points together. Now, right away, what I should be thinking is, oh, those look pretty similar, but let's actually do something to show that these are similar lines. I'm going to go from E to F, meaning I have to increase by a certain amount of units and go over by a certain amount of units. I have to increase by 5 units and go over by 3. And because it's a left to right increase, I know that the slope will be positive 5/3, which doesn't reduce any further. So now off to the side below these, I'm going to say my slope value is equal to 5/3. With G to H, I'm going to do the same thing here. I have to go up by a certain amount of units, over by a certain amount of units. I realize I have to go up 5 units, over 3 units, meaning my slope is equal to 5/3. Okay, I go to here and I say slope is equal to 5/3. What do I notice? They're the same slopes, meaning these lines are actually parallel. Let's actually summarize this in the below conclusion here. Slopes of parallel lines are equal. And if you see this notation where you see that double vertical bar, that means that these two line segments are parallel. Line 1, line 2, they're parallel to one another, symbolized by these parallel line segments that are vertical. In the opposite case, well, we see that slopes of lines are perpendicular if they're negative reciprocals, and we actually denote this with this upside down T. So if you see this upside down T like this, they say they are perpendicular line segments or negative reciprocals of each other. Okay. Now, if we go down to example 1 here, we're going to fill in this table. Slope of all lines that are parallel to the given line. Well, a slope of a given line is 2 over 3. The parallel one should be the exact same. We know that parallel lines have the same slope. Slope of the perpendicular means we flip the fraction and add the negative. In our next example, if the slope is parallel, it is the exact same slope as the slope given. What is its perpendicular line? It is 7 over 4, but we should notice this is already negative. And if I add a negative to a negative, what does that become? It's positive. So this would be positive 7 over 4. Slope of all perpendicular lines, we can actually just fill in the rest. 0, undefined. There we go. We filled in the rest because we know that all parallel lines are going to share the same slope. But now let's fill in the rest of these. 2 becomes negative 1/2, or the negative reciprocal. Negative 5 becomes 5 or 1 over 5, but positive, because if it's negative already, it is now just positive. The perpendicular line to a 0 slope, well, let's think about this for a second. If we have a 0 slope, it is a horizontal line. What's the perpendicular line to a horizontal line? A straight vertical line. And we know those graphs have an undefined slope. So this would be undefined. Similarly, if I have, in this case now, what if I have a vertical line which represents an undefined slope? What is the perpendicular line to an undefined slope? A horizontal line, meaning that the slope would be 0. All right, let's work through a couple more examples here. Draw the line passing through A, which is negative 4, 2, and a line that is parallel to the line passing through B and C. Okay, so we need to figure out, okay, for this, we have to draw a line that passes through a given point, and it has to be parallel to another 2 points. Okay, so first of all, we're going to map all the points here. Negative 4 and 2, that puts me here, and we'll call this point A. Point B and C, which I'll do in red, negative 2 and 1, and C is 5 and 4, which puts me here. So there we go, and I'm going to label this as B and C. We need another point to draw a line segment through A such that these are parallel. Well, first of all, we got to figure out what the slope of B and C is. If we figure out the slope of B and C, we know we have to rise and run by a certain amount of units. We rise by 3 units, and then we have to go over by 1, 2, 3, 4, 5, 6, 7 units. And this is a positive slope because from left to right it's increasing. So therefore, our slope of the red line, which I will draw here, our slope is equal to 3 over 7. So if the blue line has to be parallel to this line, we also have to do 3 over 7 as the slope of the blue. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So there is our separate point, and we could draw a line through there, and we would see that these share the exact same slope. So we have to find the slope of 1 in order to use it on the other graph. Now let's do a similar example, except now they're going to be perpendicular to one another. So let's draw the first point, which is A, and it's at 3, negative 2. And I'm going to do that in red again. So we go 3 and negative 2, which puts us here. And then we have to go negative 2 and negative 3, which would be here for B. And I'm going to make sure to draw that in red to differentiate it. Negative 3 and 0 and 3. So if I draw this, and then I label the points, this was B, this was C, and we want a line that's perpendicular to this red line, we need to figure out what the slope of B to C is. I have to rise by 3 units and go over by 1, 2, 3, 4, 5. So I rise by 3, over by 5, meaning my slope is equal to 3 over 5 for this line segment. And because it's left to right increasing, we know it's positive. So let's actually write this down and formalize it. The slope here is equal to 3 over 5. What is the slope of A now? What we need to do is say our second slope for the perpendicular line is the negative reciprocal. It now becomes negative 5 over 3. The fraction flips, we assign a negative, and now we can do this for our second point. So we can go 5 to the left here, so we could go 1, 2, 3, 4, 5, and then up 3, 1, 2, 3. There would be a point. Or we could do a point in the opposite direction, and that would also give us the same result here. And I need to make sure to do these, I need to make sure to clarify this because I think I exchanged the order improperly here. We need to go up 5 units, or 1, 2, 3, 4, 5, and over 3. 1, 2, 3. That would put our point here. Because we have to remember, it's change in the y over change in x. Now, when I connect these to make the points, here's what the connected points look like, and that is definitely perpendicular. And how do we know? Because we form that perfect T, which forms that 90-degree angle. So this is the slope of the perpendicular. This becomes the perpendicular slope when we do the negative reciprocal, and it allows us to find the other point. All right, example 3, the slope of L1 or line 1 is 5 over k and the slope of L2 is 4 over 3. Determine the value of L1, or determine the value of k if L1 and L2 are first of all parallel. If they're parallel, that means their slopes are equal, meaning I'm going to set L1 and L2 equal to each other, or their slopes. L1 is equal to L2, that means I have 5 over k is equal to 4 over 3. What I'm going to do here is I'm going to cross multiply, giving me 5 times 3, and then k times 4. That's going to give me 15 is equal to 4k. I divide both sides by 4 to isolate for k, and thus I get a k value equal to 15 over 4. Now this doesn't evenly reduce, so we're going to leave it there. That is the k value that makes these true. What if I want perpendicular line segments? Well, I know perpendicular line segments mean that L1 would be the equivalent of negative 1 over L2, or the negative reciprocal of the slope. So what I'm going to do is I'm going to say, well, if the first slope is 5 over k, and they're perpendicular line segments, that means I'm going to do negative 1 over 4 over 3. Well, what does that do? That reverses the fraction to be 5 over k is equal to negative 3 over 4, or the negative reciprocal. We see how from this fraction to our new fraction, we flipped the fraction and made it negative. And now I should get a k value when we cross multiply. I'll get 5 times 4, which is equal to 20, which is equal to negative 3k. I divide both sides by negative 3. And thus, I get a k value equal to negative 20 over 3. And yet again, it doesn't reduce, so we're going to leave it as that k value there. All right, determine the value of y if a is some point, b is some point, c is 8 and y, d is 1 and 0, and we know that AB is perpendicular to C and D. Well, what we're going to do right away is we're going to start by creating, first of all, we're going to figure out if AB has a certain slope and CD have a certain slope and they're perpendicular, we need to figure out what the slope of A and B is. So our slope of AB, this is going to be equal to, well, I'm going to assign this as 0.1, this is 0.2. Okay, by doing the following, I have negative 4 minus 2, which is the change in y, over 2 minus 5, which is the change in x. That means I have negative 4 minus 2 is negative 6, over 2 minus a negative 5 is negative 3. This gives me a slope of positive 2. Now, if I know that AB is perpendicular to CD, therefore that means that the slope of C and D is equal to negative 1/2, because I take the reciprocal of 2, which is 1/2, and then assign a negative here, which gives me a negative 1/2. Finally, to solve this problem for the missing value of y in this point here, we're going to assign these points here. So we're going to say that this is maybe 0.1, this is 0.2 of that line segment, and what we're going to do is say that our slope of CD, which was equal to negative 1/2, is equal to y2, which is 0, minus the negative 4, which is y1, over, we have 1 minus 8. That gives me 0 minus minus 4, which becomes a positive. And so we get 4 over 1 minus 8 is going to be negative 7. And there is my value for what our simplified solution is. But what we need to do here is say, and I actually need to go back and make an adjustment here because I just realized I incorrectly put in one of the variables here. We have to have 0 minus y in the numerator over the change in x, which is 1 minus 8. This gives us a value of negative y over 1 minus 8, which is negative 7. So we get negative 1/2 is equal to negative y over negative 7. The double negative actually makes this positive. So we now know that that fraction's positive. If I continue this off to the side here, I'm going to have negative 1/2 is equal to y over 7. And we know just from the last problem, all we must do is multiply our denominator out, or from equations even, and I get negative 7 over 2 is equal to y. And thus, the y value that makes this equation true is that value here. All right, write the equation of each line. The line parallel to y equals 1 over 3x with the same y-intercept as y equals 6x minus 5. Okay, so if it's parallel, this is what we need to be reading into. If it's parallel, then their slopes are equal. That this slope will be equal for our next equation. And if they say the same y-intercept, what are they saying? It's the same b value, where b is equal to negative 5. So if we put these two things together, therefore, because it shares the same slope, it'd be y is equal to 1/3 x. And then it shares the same y-intercept as that second equation, which is negative 5. There's our equation right there. All right, the line passing through the line segment, or passing through the point 0, 5, well, we can label this as an x and y because they're specifically telling us a point on the Cartesian plane, and it's perpendicular to the line y equals 2x plus 9. Well, what do we know about perpendicular lines or in slopes of perpendicular lines to one another? It means that if it's perpendicular to this given line segment, then the slope must be the negative reciprocal. So if slope 1 is equal to the 2, or the m value, we know m2 is just going to be the negative reciprocal, or negative 1/2. So now we have to solve for our y-intercept here. We say that, first of all, y is equal to mx plus b. We have an xy, so that's 5 is equal to m, which we found to be negative 1/2, because that's the perpendicular slope, times x, which is 0, plus b. Anything times 0 is just gone. So now we have 5 is equal to b, which is our y-intercept. Now what we can do is piece this all together in our equation and say, for step 2, our equation for this line, or the line, is y is equal to negative 1/2 x. And then our b value was positive 5. The line passing through the origin and perpendicular to x equals negative 2. Okay, well, if they're talking about the origin, that means our x and y is equal to 0, 0. It's right in the middle of the Cartesian plane, and it's perpendicular to the line x equals negative 2. Well, let's think about this graphically for a second. If I draw this and I have x and y, well, x being equal to 2, what are they describing? This is a vertical line at x equals negative 2. When they say x equals negative 2, we have a vertical line. And so if it's perpendicular to this and it passes through the origin, then our line must be simply along the x-axis. Because they say it passes through the origin, which is right here, 0, 0, and it's perpendicular or forms the 90-degree angle to our other line. So thus, our slope is actually 0. And so when we go to our equation here, our equation is going to be y is equal to mx plus b. We know that the slope is 0, so 0 times x, and then plus our y-intercept is at the origin, and that's 0, so our equation of our line is y is equal to 0. That is the equation of the line passing through the origin perpendicular to y, x equals negative 2. Finally, we have a line that passes through the y-axis, or that is parallel to the y-axis, passing through the point 2, negative 5. Yet again, I think it's always a good idea to visualize these things if possible. So I'm just going to draw a Cartesian where we have x and y labeled. I'm going to do a point of 2 and negative 5, which would put us roughly around here. And they say we have a line that is parallel to the y-axis and passing through this point, meaning if I'm thinking about the y-axis and I draw that in red, it is an undefined vertical slope. And furthermore, if I have a line that's parallel to that, it must be a vertical line passing through that given point down here, which was 2, -5. So if it's parallel and we know that the y-axis straight up as a vertical line is undefined, then it must be that our new slope is undefined. So we say y equals mx plus b. This is the equation we think we need to use. Well, first of all, if we look at our equation here, we should recognize that there's no slope. It's an undefined slope. And furthermore, a vertical line, unless it's directly right on the y-axis, it's never going to cross the y-axis. So we know that this also doesn't exist, no y-intercept. So now, does it make sense to use an equation in terms of y? No. This is where we go and say any vertical line is going to be written as x is equal to whatever the x value it passes through, which in this case is +2. There is your equation for this line segment. All right, below is to check your understanding. I would definitely do that for these ones because slope of parallel and perpendicular lines you want to be very familiar with, as these tend to pop up a lot later in math, and you really want to be solid on this foundational piece.